All right, this is for test 4, review A. Okay, so it's not every single question on the review, but most of them here that I think that you need. All right, so this first question here, you're solving a triangle. Now notice it's not a right triangle. So the triangles that we solve for this test, we use 2 sets of formulas. Okay, so we have, just over here, make some notes, laws of sine and then laws of cosine. Okay, so these solve non-right triangles. Okay, so we got to make a decision a lot of times. All right, which set of formulas do I use? So laws of sine, what you're looking for to use laws of sine here is you have an angle and the side that are across from each other. Okay, angle and the side that are across from each other. If you don't have that, then you have to use laws of cosine. Okay, now another way to look at it is this way. You can use laws of sine for angle, angle, side, or angle, side, angle, or the ambiguous case, side, side, angle. For laws of cosine, you can use it for side angle, side, 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 and side angle, side. Okay, this is much easier to remember right there, though. All right, so let's look at this case. In this case, we have, what, 2 angles in one side. Now notice that the angle across from the side's not given, but you could find it, right? Okay, so, always, if you have 2 angles, you should automatically be able to find the third. So I'm doing 68 plus 44 is 112, and then 180 minus 112 is 68. So is that the same as the other one? Did I do that right? 68 plus 44 is 112, 180 minus 112, 68. Okay. Now there's actually a shortcut on this question. So yeah, this would be laws of sine. Right. Y'all see how C would also be 12? It's isosceles. So you don't really need laws of sine to find out what C is. Because if these 2 angles are congruent, then these 2 sides are congruent. Okay? Now, we'll set it up to find the B one, though. Okay? So now to find the B one, remember how laws of sine work? Well, it's like A over sine of A equals B over sine of B and C over sine of C. Now, what's easier to do is just look at the pattern. It's the side over the sine of the angle that's opposite, right? Okay. So let's see, what's the given one here that's going to help me the most? 12. Okay, this one over this one. So 12 over sine of 68 equals, now what are we looking for that we haven't found yet? The B. Okay. Now we actually figured out C by a little trick. It was isosceles. So, chance it may not be isosceles on the test. You would actually have to find that one. Now, all right, 12 over sine of 68. Now let's do the B one. So that would be what? B over sine 44. Okay, now how do we solve there? Just what? Cross multiply, right? Uh-huh. When you're finding an angle. Okay? Anytime you're trying to find an angle, you're going to use inverse. So in this case, do I need to use inverse on this problem? Nuh-uh, because you're finding the side. Okay, so anytime you're trying to find an angle, you can use inverse. So just cross multiply, divide by sine 68 on both sides. All right, and just throw that in the calculator. Y'all going to be okay if I don't finish out these problems on some of these, just for time's sake? Okay, so y'all can just punch that in the calculator. What mode would it need to be in? Degrees, okay. All right, now, all right, here's the rough ones. Okay, side angle. Okay, so this is where you have to determine if you have 1 triangle, 2 triangles, or no triangles. Now, what I'm going to do before I do this problem is let's just kind of have a whole reteaching thing on this, okay? So, I don't think, did anybody ever see one that had obtuse triangle? Okay, so I'm not going to do the obtuse case. I'm going to do the two acute cases, okay? So, you remember the way that we draw the angle every time? Well, we put, let's just say this is 42, and then you remember where we put the sides? Right, you put something on the bottom. So, yeah, we'll just say C, and, all right, and let's put this one as like A or something, all right? No, wait a minute, that's side angle side. It would have to be right here. Okay, so the side angle, all right? So we draw that the same way every time, right? Now, let's draw a similar one, and let's talk about what happens when A is bigger than C, or C is bigger than A, or what happens? Okay? All right? It all depends on how big C and A are. Well, you draw it the same way every time. I'm just using A and C. It could be anything right there. There's going to be numbers right there. Okay? Now, what happens if C is bigger? If C is bigger, it's one triangle. Okay? So if that's the bigger side, it's just one triangle. You don't have to do anything. You have to probably solve it. Okay? Now, what happens if A is bigger? Or let's just say this, C is smaller. Okay? What do we have to do? Find the height. Right. Okay? You got to find the height by using right triangle trick. Okay? So you'd have to sketch in the height. Okay? Now you want to put some numbers in real quick. Okay, just to do it. All right. So if C has to be smaller, let's say that C is 7 and that A is 10. Okay? So how would we find the height? Now remember, the height's going to form a right angle, so you got a right triangle. Sine, okay? So you take the sine of 42. Remember, that's what? Opposite over hypotenuse, so h over 10. So we get 10 times sine 42 equals h. Okay, now, before we actually say what it is, all right, let's think about what has to happen for it to make sense. Right. The h has to be smaller than 7 because it's the height and the 7 is the hypotenuse. So the height, or a leg of a triangle, can't be bigger than the hypotenuse. So what happens if it turns out to be bigger? No triangle, because it can't exist. Yeah, pray it's bigger. All right, now, what if it's the same as the hypotenuse? It's one triangle, okay? And if it's smaller, like it's supposed to be, then it would be two triangles. You want me to write that down real quick? Or let me figure it out, and then I'll write it down. All right, so now, did somebody punch it in for me? Okay, so now, it is smaller, so that means this would be two triangles. Okay, so now, let me write this down for the H part, okay? And I'm going to PDF this for you so you can pull it up to study, okay? All right, so what happens again if H is smaller? What happens? Two triangles. Okay? All right. What happens if its H is the same? One triangle. Okay? And then if H is bigger, yeah, no triangle. Okay? All right. Now, let's look at the actual question. All right. Now, and this is we're talking about the way you draw it every time with side angle. Okay? Where did I tell you put the angle every time? The bottom left. Okay? So there's the 65. Okay? So, where's the 12 going to go? Am I going to put, would that go here or here? It has to go across from it, right? So, right, what little a goes across from big A. All right, so that means the 7.8 would be right here. All right, so now look at the sides. Which the 12 is the bigger one, right? So what happens when the opposite side is the bigger one? Come back. What happens when the opposite side is bigger? One triangle. Okay. So you don't have to find the height unless this was switched. Okay. So this would be just one triangle. So this would be choice A, right? Now we would have to solve it real quick. Okay. Do I need to go over solving that one? Okay. Well, you would have to use inverse sign somewhere. I think we need to. Okay. Let me. I'm gonna try to copy that. All right, y'all help me remember it. 65, 12, and 77.8. All right. So 65, 12, 7.8. All right. Help me out with the labels. That was A. All right. What was 7.8? C. So that's going to be big C. That'll be big B, and that'll be little b. Okay. Now, y'all see my nice ratio that I have with 12 and 65? Okay. So it would be 12 over the sine of 65 equals, all right. Now, what other ratio could I use to find something? Could I use the B or the C? The C. Because what, there's too much missing on B, you don't know either one, so you got to use the C. So 7.8 over sine of C. All right, let's cross multiply. So we get 12 times sine C equals 7.8 times sine 65. Okay, now what? You divide by 12. Okay. Now here's the thing. When you divide by 12, that's not going to be C. That's going to be the sine of C. This is where we do inverse. Remember, who asked the question about the inverse earlier? Ethan. He's not even here. All right. So how do we know that we're using inverse here? Because what are we finding ultimately? We're finding an angle, so we got to use inverse. Okay. Now I'm going to punch all that in. Right here first, okay? So let me punch in 7.8 times sine 65 divided by 12 is like 0.5891 something. Now inverse sine of that. Okay, so I got, what are we rounding to? This nearest degree, doesn't it? 36 degrees. Now, what's something I probably need to do right here? Store it. Because it's not exactly 36. So I'm going to stow it in C. Okay, now, do y'all see how we're going to find angle B now? We just add that to 65. It's about 101. And then subtract that from 180. Okay, so again, this angle is about 79 degrees. All right, I'm going to store that one. See, I store everything because, you never know when you're going to need it. All right, now y'all see how we're going to find B? Now that you got that 79 degrees, you can find the B angle. Right, so you do B over sine of 79 equals, right, 12 over sine 65 and cross multiply. I'm not going to finish that one. Okay, just for time's sake here. Now, what would be the problem here with like using 7.8 and 36? Yeah, I guess you could. All right, but 7.8 or 36 was, I guess you could do that too. All right, let's look at this one. All right, let's see how many triangles we're going to have this time. All right, so that's the 50-degree angle. This is 22. This is 30. All right, now tell me what you think here. Now the smaller side's opposite of the angle. You got to find the height. Man, y'all need to study. Okay. All right, go back. Okay. And it's been spring break. I know it's been a long time. All right, look at this. All right. So if C is the bigger one, if the side opposite is bigger, it's one triangle. But if it's smaller, got to find the height. All right, and that's the case here, right? Got to find the height. All right. So all right, help me remember it, okay? 50, 22, and 30. 50, 22, 30. Okay, so now we got to find this height. All right, let's call it H. All right, so I can use my right triangle right here. H is opposite. 30 is the hypotenuse, so I would use the sine ratio with my right triangle trig here. So H over 30. Okay, so we'll do 30 times sine 50. All right, now, before we say what that is, let's just go through the scenarios. What if H is smaller than 22? Two triangles. What if H is 22? One triangle. And if H is bigger than 22, no triangle. That's what we're hoping for, right? Okay. All right, so let's see. What is 30 times sine 50? It all depends on that. All right, I got 22.9. Did y'all get that? So, can that be 22.9? Can a leg be bigger than the hypotenuse? No. No triangle. All right. Now, they gave you all three on the review, so you don't know which one it's going to be. Okay, I'm banking on the two triangle one. Okay. And I told y'all this, remember a while back, I said the two triangle one last year, it was multiple choice. And there was only one choice that had enough information for two triangles. So they never had to work them out. They were lucky. All right. Now, I'm betting this is the third question. This one's probably going to be two triangles. Okay? So, pack a lunch. This is going to take forever. All right. Here we go. So we got... All right, how do we find the height? You sketch it in. You just use right triangle trig. Look, you look at this angle, all right, the given angle. How is H related? H is opposite, and you're given the hypotenuse. So opposite and hypotenuse, you can use the sine ratio. Okay? All right, this is 51. All right, this one's 16. This one's 18. All right, now, what happens when the side opposite is smaller? What does it mean I have to do, or what does it mean? Can I just say it's like one triangle, or do I have to find the height? Got to find the height. Okay, so let me redraw it and find the height here. This is what, 51, what was it? All right, 16 and 18, was that it? That was A. What was 18? 18 was B. That's going to be my B. So this will be my C and be my little c. All right, let's find the height. Okay, so now, all right, we use the sine ratio again. So the sine of that angle, that 51, is opposite over hypotenuse. So we get 18 times sine 51 is the height. Okay, let me calculate. 18 times sine 51 is about 14. Oh, I got a good one for you. Y'all look up. That sign right there in front of 14 means what? Approximately. It just reminds me that I rounded that. That's what somebody called that in Algebra 2. The bacon symbol. So we were actually doing this. I said, that's bacon. All right. Now, all right. So now, what does this mean since that height is 14? It's two triangles. Oh, crap. Yeah. Okay. Now, so with two triangles, you have to solve both of them. So there's 6 answers to this question. All right, let me tell you a story about, like, the first time we did dual enrollment. If you missed one of the 6 answers, you missed them all. Doesn't do that on that. That was Hawks. Okay, it's math. We're using my math class. All right. What now? I don't know. I don't know. All right. So now I'm gonna get rid of this because I know I got to do 2 triangles now. All right. So really don't need the height anymore. It was just to tell me that I've got 2 triangles. Now remember when you do the 2 triangles, you do it in a different color. I use primes, okay, so you can keep them separate. So this is A prime, C prime, B prime. This is still 51. This is still 16. This is still 18. Now what about everything else? It's different. Okay, you got to find it. You're right, but it's all different from there. Okay. Now, all right. So yeah, I could find B, angle B first, couldn't I? All right. So. Right, 16 over sine 51, and we're gonna have to store a lot of stuff on this question over sine B. Okay, so cross multiply. We get 18 times sine 51 equals 16 times sine B. All right, now what? Right. Okay. Right. So I'll type this in. Take inverse sine of it. 18 sine 51 divided by 16 is like 0.8743, and so that's the sine of B. So I take the inverse sine of that. All right, so I'm getting B here. And I think it says round the angles to the nearest degree, doesn't it? So that would be approximately 61 degrees. All right. Right. Very good. Okay, here remember. You subtract that one from 180 to get the other one. So remember what you don't do. You don't tweet about it. You don't take a selfie. You don't do anything else. You know, I don't care how bad your stomach's hurting and you got to go to the bathroom. Okay, you find the other angle immediately. And the way you find the other angle, the way you find B prime, is you just take this one and subtract it from 180. Okay. So now let me store this real quick. I'm going to store that in B. All right, so remember it's stored in B, and now I'm going to say 180 minus that, okay, is 119. Now, I'm going to store that in D, okay, in case I need it. All right, well, I'm going to write myself a note that I stored it in D. Now, do y'all see how we're going to find angles C in both of them? It's pretty easy from there. You just add the 2 angles, subtract from 180. So we'll say 51 plus angle B, which I stored in B. All right, it's like 111.96, and I'll subtract that from 180. Okay. All right, so this one's about 68. All right, just add those together. Subtract from 180. Okay. All right. So same thing over there. Now, do you want me to finish it out and find the C, or it's pretty easy from there? Okay. All right. But remember, what's going to happen is you're going to find this angle first, and you immediately take that angle and subtract it from 180 to get that angle. All right. Crucial. Ooh, I'm glad I'm done with that. All right. This one's, all right, this is a formula you're going to have to know. Y'all check your reference sheet for me to make sure I'm doing the right formula. All right, I think it's 1/2 times side 1 times side 2 times sine of the angle. Is that right? Is that right? Okay. All right, so you just throw it in the calculator. All right, 1/2 times 23 times 43 times the sine of 34. Okay, really should be sine of the angle, right? Okay, so just throw that in there. Now, remember what I told you? Don't look at the formulas. What the formulas might use, like A, B, and C, you don't need that because it's just the 2 sides and the angle. Okay, doesn't really matter what's A, B, and C on that. All right, let's solve this one. All right, now. All right, on this one, All right, let's notice something. You got the 40-degree angle. You can't find the other. If you had one other angle, you could find the other one, but you don't have the other angle. Now, look across from 40. Are you given the side across from 40? Yeah, it's a variable. Okay. So what I'm trying to say is the angle and the side that's opposite, you don't know both of them. So what am I getting to? You can't use laws of sine. You have to use laws of cosine. Now remember, once you use laws of cosine once, you can finish it with laws of sine. Okay? Right. Remember, we always find smaller stuff first. Now, so here's what we're going to do. All right, so laws of cosine, we got to figure out which one to use. We're going to find the third side first. Okay, so when you have side angle side, you find the third side first. All right, laws of cosine, a squared equals b squared plus c squared minus 2bc times cosine a. Be really careful. I see a lot of kids make a mistake. They put sine right there. All right, it's laws of cosine, okay, not laws of sine. All right. So now let's fill it in. So you get a squared. And so remember there's three of them. I'm using the a squared formula because I'm trying to find a. All right. So this will be equal to 25 plus 36 minus 2 times 5 times 6 times cosine of 40. Okay. Now the side angle side one is pretty easy because all you have to do is just throw that in the calculator, every single bit of it, and then do what with it? I'm throwing it in the calculator. What do I do after I do that? All right, I got 15 point something. Is that it? Is that A? That's a squared. So I need to do the square root. All right, and I'm going to save it or store it. All right, so it's about 3.8. No, 3.9. All right. The first angle that you find, okay, that tells you the other corresponding angle in the other triangle. Okay. Now, all right. So once I have this, and I'm gonna store it in A. Okay. This is about 3.9. Now that you have the side opposite, you can use laws of sine, and you'd find smaller angles first. All right. Do y'all want me to find the other two angles real quick, or could y'all do that with laws of sine on your own now? I'm assuming you can do it. Which angle would you need to find first? Y'all look up a second. I found this side. What angle would I need to find first here? Which angle would I need to find, C or B? B, because it's the smaller one. Because there's a chance that angle C would be obtuse. And if it's obtuse, laws of sine is not going to find it. Okay? So always find the smaller angles first when you use laws of sine. Okay? All right, how would I find it? Because it would be the smaller angle. Because it's across from the smaller side. Okay? So this is the bigger one, right? So there's a chance that angle C might be obtuse. And if it's obtuse, laws of sine is not going to work correctly. Okay? So when you use laws of cosine and you finish by laws of sine, find smaller angles first. Find small angles. Okay? All right. All right. But it would be smaller than C. See, we've already got that angle. Okay. So the next to the smallest angle would be angle B. Because the smallest angle is across from the smallest side. So B is not really the smallest angle. It would be the next to the smallest angle. But it would not be the biggest angle. Okay? All right. Let's do this one. Okay. Now, I'm given a triangle. I've got all three sides. A, B, C. So this is 9, 8, and 6. All right. Now, remember what I told you. If you just remember this every time, you don't have to, remember a bunch of stuff. Find what first? Which angle? Right. Find the small angles first. Okay. So here's the order that I'm going to work in. I'm going to find angle C first, and then I'm going to find angle B, and then last I'll get angle A by using angles B and C together. Okay. So you never want to use. You want to put off the obtuse angles to the end of your problem. Now, so let's find the C first. Right. So C squared equals A squared plus B squared minus 2AB times cosine C. Okay. So be 36 equals 81 plus 64 minus 2 times 9 times 8 times the cosine of C. All right. Let's clear it up. All right, 81 and 64 would be 145. And then 2 times 9 times 8 would be 144. All right, now, y'all look up a second. What do I do from here?
Oh, you have to negative 145 or bring 145 up.
Right. So what's the thing that you don't do?
Subtract.
Right, you do not subtract that.
144 is part of the
Right, very good, Garrett. All right. So there we go. All right, so we got 36 minus 145 is negative 109. All right, now what? All right, divide. All right, Ethan, look up. That's not going to be C, but that's going to be the cosine of C. So let me punch it in real quick. Negative 109. He was supposed to tell me that. All right, look what I'm finding. C is an angle, right? Now, this ratio right here, this is 0.7569. That's not C, that's the cosine of C. So this is where I would have to use inverse. You know what we're saying? That's what you asked me a while ago. Okay. So inverse cosine of that would be about, so this would be C, would be about 41 degrees. All right. I have no idea. All right, I can't look at that right now. I'm on my thing. Y'all wanted a video. You wanted all these problems, so I got to do it. Now, all right, from here, we said the next angle that we would find would be B, right? All right, but now we could use laws of sine. Okay, I'm not going to finish it out, but if I use laws of sine, I could do 6 over sine 41. Remember, I stored it. You'd have to use the exact value. I'm telling y'all aren't going to store that, and you're going to put it in, and you're going to have a rounding error. All right, equals, yeah, here we go. Okay, cross multiply, solve. Now, once you get B, right, you could add it to C and then subtract from 1/8. And so there's a possibility that A is going to be obtuse, and that's why you're finding it last. Okay. Yeah, you would have had to use law of the cosine for the whole problem. Okay. But if you wait to the last part, you can get away with just using laws of cosine once and then finishing it with laws of sine. All right, here's the area. All right, what was this formula when you have all three sides? K equals S times the square root of
A minus,
S
minus A.
minus A times S minus B times S minus C. Now what's S?
S is the all over that. No, the half of
It's right. S is the semi-perimeter,
half of
just half of the perimeter. Okay, so perimeter here, 11 plus 7 plus 8 would be 26. So S would be 13. Okay, so this is 13 times, right? 13 minus 11 times 13 minus 7 times 13 minus 8. Okay, just throw it in the calculator. Oh, I really don't want to do this problem. All right. Two ships leave a harbor at the same time. One ship travels on a bearing south 12 degrees west at 15 miles per hour. All right, let me draw my thing here. Never eat sour worms. All right, here we go. South 12 degrees west. Okay, now where's that 12 degrees? Is that here or here? Bottom. But the bearing angle is the angle formed with the y-axis. It's like the opposite of the reference angle. All right. Now this one goes 15 miles per hour. Now y'all look. This is real tricky. It doesn't say 15 miles. It says 15 miles per hour. And he's going 2 hours, so it's really 30 miles. Okay? All right. The other ship goes north 75 degrees east. So that's like over here somewhere. Now, where's that 75 degrees going? Right with the y-axis. Okay? So that's going to make this angle 15. Okay? Now what happens here is it really just makes a big, an obtuse triangle right here. All right? So here's what you have to do. You have to find this angle. All right? This one's 90, right? So you do 90, 12, and 15. It's 117. Okay? So this is really what we're getting. Hang on. Messed up. There we go. That's 117. So this is 30. And now this other one goes, the other ship travels at 10 miles per hour. So 10 times 2 will be 20. Now they're looking for the distance that the ships are apart. So this would be the unknown. I'm going to call it A. And notice it's not a right triangle. It's obtuse. So you have to use laws of sine. So these two match up. I can do A over sine of 117. All right. So, a lot of times when we do a t-table, kind of the standard thing is go from -2 to +2. I'm going to do a lot more than that this time. Okay. So I'm actually going to go all the way back to say maybe like -4. Okay. So we go, and let me do this. I'm sorry, guys. Let me change this back to a 2. Okay. And you do it with a 2 right there. Won't get too big that way. All right, so we'll do 2 to the x. Now, so we're going to go -4 to like +3 or something, okay? But just a lot of points, so you can get the idea of what these equations kind of look like. Okay, now, let's get y values. All right, so we should know how to get the y values, right? What do I need to do? I'll start down here because they're going to be easier. How do I figure out what the y would be?
Put 3 as the base.
Yeah, 2 to the third power. So you're taking 3 and you're putting it in place of x. So 2 to the third would be 8. Okay. And then 2 squared would be 4. Okay. 2 to the first power would be 2. Now this one's really important because this one's going to be in almost every graph. 2 to the 0 power, anything to 0 power is 1. Okay? And we're going to take advantage of that fact later. Okay, now let's plug in -1. Now, this will make you think. So 2 to the -1, now that's not -2. 1 over 2, right? Does that make sense? When exponents are negative, we move them down to the bottom and make them fractions. So 2 to the -1 would be 1/2. Okay? Now, I'll try to think about it this way. 2 squared is 4. So 2 to the -2 power would be -4, but it would be what? 1 over 4. Okay? Now, what about 3? 2 to the -3rd power. 2 to the third's 8. So it would be 1/8 if it was -3. Okay? And then -4. 2 to the 4th is 16. So this would be 1/16. Okay? Now, let's look at what these points look like. And so what we have to do the first time that we graph one of these is I have to show you all these points so you get the idea of what they look like. But in the end, when you do them, all you're really going to be using is probably going to be just those 2 points right there. Okay, I'll tell you about that more in a second. Now, let's graph all these points. So we got 3, 8, all right, 2, 4, 1, 2, 0, 1. Now, notice that it's a curve. It's not a line. Okay, so these are exponential. They're curves, all right? Now, once we get over here to the negatives, notice what's happening to the values. Okay, got -1 and then 1/2. So that would be about right there. Okay, now, see if you can kind of pick up on a pattern in this. All right, when x is -2, y is 1/4. Now, where's 1/4? Especially compared to a half. Where is 1/4 at? You know, half is halfway. Okay, so what's 1/4? Half of halfway. Does that make sense? A fourth would be half of halfway. Okay. Now, and here's where it gets really hard to start graphing it because what do you notice about these numbers? What 1/8 would be half of halfway, right? We just keep halving, don't we? And so what's happening is when we keep halving, it's going to get closer and closer to this value, which is 0, right? It's getting closer and closer to 0, but let's think. Let's go out to say -100. Would that make it 0 if x was -100? No, it would just be really, really small, right? Y'all get the idea that these are getting smaller and smaller and smaller, right? Okay, but right, it would never actually touch or cross 0, would it? Now, that concept is called this value that it approaches, but it doesn't never touch it or cross it, is called an asymptote. Okay? That's how you spell it. It took me about 3 years to learn how to spell that. After the 3rd year I taught pre-calculus, I finally learned it. Okay? So it's called an asymptote. And the idea is it's a curve that gets closer and closer to a line, but it doesn't touch that line. Now, the actual line is called the asymptote. So the way we graph the asymptote is we do it with a dotted line. And so in this case, this asymptote has the value of 0 because this curve or those points are getting closer and closer to 0 but not touching it. Now I'm going to draw my curve through my points. And so this curve All right, it's going to get closer and closer to 0, but it's never going to touch it. Okay? All right, it's like you and your siblings in the back seat on vacation. I'm not touching you. I'm not touching you. I'm not touching you. So it gets closer and closer, but it never touches. Okay? All right. Now, so really what happens is you don't need all those points to tell that. All you need is 2 points, and you have to figure out what is the asymptote. How do you find it? Now, I'm going to show you how to find the asymptote and how to come up with these 2 great points right here. Okay? So, right. Okay? And so I'm going to show you how to get to those 2 specific points because they're going to be the nicest points on the graph too. Okay? So let me show you, I'm going to lay out 3 things. So those 3 things are how you get these 2 points. Yeah. What was that? Was that my clock? No, it wasn't. Okay, I don't care. All right. Now, and how to get the asymptote. So 2 points and an asymptote. That's 3 things. Now, let's look at one. Let's try this one. Okay, and I'm going to show you like a different approach to it. But you don't really have to do it this way, but it's good to know by, you could do this by transformations here. Okay? All right, now let's add more to it this time. Let's do 2 to the x. But this time, you'll watch, we're going to do 2 to the x plus 1 minus 4. Okay? Now, let's go back to this. All right, I want y'all to think a long time ago, like way back in September. Remember that day I gave you that lab? We did absolute values like this. Okay? And we learned transformations for the first time. And then we took that topic and we beat it to death, right? We did parabolas. What else have we done? The snake shapes. Okay? So we've done all kinds of stuff with transformations. So you could actually do this that way. You could take the parent t-table and do the transformations to it, but you don't really have to make it that difficult. Now, what I was getting to is it's kind of similar to this. So the exponent part is like the inside part of the function, and then this part is the outside. You remember how we shifted it? So what would this do to the graph here, or this absolute value graph? It would shift it how? Left 1, right? Remember it would go in the opposite direction? And then this one would make it go down 4. Now, this is the one that's important for the asymptote. Okay? This part right here. So let me give you a 1, 2, 3 list here. So the first thing, and by the way, we call it a horizontal asymptote. Okay? Because there are other types of asymptotes. Okay? There's vertical asymptotes, and there's also called slanted asymptotes. Some people call them oblique. I call them slanted because I can't spell oblique. Okay? So we got a horizontal asymptote. All right, here's the way you do it. The horizontal asymptote, listen, this is what it is, the vertical shift. Okay, so whatever the vertical shift is will tell you your horizontal asymptote. And now, when you say the horizontal asymptote, you don't just say a number. You have to say y equals that number. So what is my vertical shift right here? This would shift it how? What? Down 4. So that means the horizontal asymptote will be y equals -4. Okay? This is going to be that line that the curve is going to get closer and closer to but not touch. Okay, now let's graph it and get it out of the way. So we're going to go to y equals -4. And it's horizontal line, so it'll be a horizontal line through -4, and my curve in just a minute, it's going to get closer and closer and closer, but not touch that line. Okay, so there's the first thing. All right, now the other 2 things are just 2 ordered pairs. You don't need all those ordered pairs I listed earlier. I only did that so you could see the idea of how it gets closer and closer to a thing, but it doesn't actually become that thing. Now, here's what you do. You ask yourself a question, all right? And we're going to make a t-table with these values. All right, we'll say, all right, what makes the exponent 0. Okay, so in other words, what value of x would make the exponent turn into 0? -1, right? So that's going to, I'm going to do a little t-table, and that's going to be my first value of my t-table is -1. Okay, now the other question is this. Okay, it's very similar. Instead of 0, we're going to say 1. All right, so what makes the exponent 1? Okay, so what number would I plug in right here? It would be 0. Okay, so I would plug in -1 to make the exponent 0, and I would plug in 0 to make it 1. Now in a minute, sometimes it's pretty easy to tell what makes it 0, because we do that a lot in here, don't we? Okay, but sometimes what makes it 1, it's like a little complicated. You might not can figure it out in your head. I'll show you why you can do it in a second. Now, so all we're going to do is get the y values. Now let's talk about this before we plug them in and get the y values. Why would we choose these values? Remember, these are going to be the nicest numbers on the graph. What happens when you raise something to the 0 power? It's always 1, right? And so it's a nice number, isn't it? 1's a nice number. Okay? So what happens when you raise something, or when the exponent is 1? Something raised to the first power is itself, right? Something raised to the first is itself. 5 to the first power is 5. Okay? So y'all understand why we want those two values out of all the ones that we listed? Okay, they're the nicest ones. Now, to get the y values, all we have to do is we just take these and we just plug them in. Okay, so let's take -1 and let's plug it into my function. So if I plug in -1, that's going to turn the exponent into 0. So that would give me 2 to the 0 power minus 4. All right, now let's calculate this. All right, 2 to the 0 power would be 1, and then 1 minus 4, yeah, -3. Okay, so when x is -1, y is -3. Okay, now let's plug in 0. Okay, so plug in 0 right there. So 0 plus 1 would be 1. So I would get 2 to the first minus 4. Okay, now let's calculate that. 2 to the first is just 2, and 2 minus 4 would be -2. Okay, now those are my 2 points that I need. So notice I need 3 things. I need a couple of points, and I need the asymptote. Okay, the vertical shift, and that's going to tell me the asymptote. Now let's graph my points. I got -1, -3. All right, and 0, -2. Now remember, it's not a line, it's a curve. So I'm going to draw a curve through these 2 points. And so how do I know how to draw the curve through the 2 points? Well, what does the curve have to do? It has to go through these 2 points, and it has to, what? What's it going to do to this line? Right, it's going to get closer and closer to it, but not touch it. Okay, so I asked this question 100 times in pre-calculus. I ask them all the time, what do we do to asymptotes? And their answers is we chase them. We get closer and closer to them, but we don't touch them. All right, so I'll start my graph over here. Since it's going downwards, I'm going to go this way. So I'll just draw an arrow like this. So I'm going to draw a curve through these 2 points. And when it gets close to this line, it's going to get closer and closer, but it's never going to touch it. Okay, so these aren't really difficult. Okay, but there are just 3 things there that you have to do to kind of get to that. Yes, question?
So we draw it where it might look like it's touching.
That's okay. Yeah, I mean, it's not supposed to, but, sometimes it's hard to draw it closer and closer without actually touching it. Okay. All right, but just do the best you can on it, okay? Now, let's look. Let me do, like, one more example. Okay, and I'm going to let you guys graph some. All right. Let's do this one. Let's do f of x equals, now this time I'm going to do a negative one, okay? A negative coefficient. Let's do -3. to the x minus 2 power. Alright, now I'm going to change this up in just a minute, but I just wanted to do this first to kind of get your reaction here. So a couple people in 5th period, we did a problem like that, and they thought that the vertical shift would be down 2 because of this. No. This would actually shift it right 2 because the minus 2 is in the exponent. So here's the thing. You really don't have anything out here to shift it vertically. So what do you think that means about the asymptote then? Right, it's 0. It's like the very first one that we did. Okay, so if you don't have a number that's doing a vertical shift, your horizontal asymptote is y equals 0. A lot of the ones that you're going to graph today are going to have y equals 0 for the asymptotes. Okay, now I'm going to throw in one just so we can see it. Okay, let's do like plus 1. Okay, so I'm going to abbreviate this time. So my horizontal, I'm going to say HA for horizontal asymptote. All right, very good. Y equals 1. Because what the vertical shift in this would be what? Up 1, right? Okay, and the horizontal shift would be right 2. But you don't need to have to know the horizontal shift. All you need to know is the vertical one. Now, let's put in some values here. Okay, now, what x values do I want to choose? I want to choose x values that make the exponent 0 and 1, right? So, all right, what would make the exponent turn into 0? Positive 2. 2 minus 2 would be 0, so a positive 2. Okay, now, what would make it 1 if it was 3, right? Okay, now, there are going to be some cases where you get something right here, and it's kind of complicated. Okay, what if I had like 3x minus 5? Now, we're pretty good at saying what makes that 0. Okay, so it'd be what, 5/3, right? Now, what would make that 1? Yeah, it would actually be 2. Okay, now, what if we couldn't figure that out? Well, if you can't figure out what makes it 0 or 1, set the sucker equal to 0 or 1 and solve it and see. You get what I'm saying? If you can't figure out what makes it 1, go to the side of your paper, set it equal to 1, and solve it and see. So I would add 5. Okay, that would be 6. So x would be 2. Okay, so if you can't figure out what makes it 1, set it equal to 1 and solve it and see. Okay, now most of the time you'll be able to figure it out, but sometimes you won't. You'll have to do a little bit of work. Now, how do we get the y values now? Plug them in. Okay, now, so if we plug in a 2, that's going to turn that into 0. All right, so we'll get, all right, negative 3 to the 0 power plus 1. Now, you got to be careful with this negative right here. Now, 3 to the 0 power would be 1. But then this negative would mean the opposite of that. So it would be negative 1. All right, does that make sense? Okay, so that would actually be negative 1 plus 1. And right, that would be 0. Okay, now let's plug in the 3. Okay, so we plugged in 3. 3 minus 1, 3 minus 2 would be 1. So we would get negative 3 to the first power plus 1. Plus 1 right there. Okay, now, negative 3 to the first power would really just be negative 3. And negative 3 plus 1 would be negative 2. Okay, now let's graph it. So the horizontal asymptote is y equals 1. So you go up to 1. And you remember, yeah, we should have done it at first. All right, so what are we going to do there at 1? Yeah, dotted line. Okay, so this is the line that I'm going to get closer and closer to, but I'm not actually going to hit it or cross it. Okay, now let's do my points. I got 2, 0, which would be right here, and then 3, negative 2. Now this time, notice how it's different. The points are actually below the line, right? So, earlier we were chasing it from above and kind of chasing out this way. Right. Because it's the negative, it's taken this curve that would have been on top and it's reflected it. Okay. So now, instead of like chasing the line downward, this one's going to be chasing upwards. Okay. So I'm going to do my arrow here and just go down and get closer and closer, but not touch it. Okay. So I can go to Taylor and say, I'm not touching you. I'm not touching you. She's not watching. I'm not touching you. Still not touching you. See? That's an asymptote. All right. Now, all right. Let me give you some of these. Let me go ahead. I'm going to put this up here. All right. You're going to do, I've got this sheet for you. They're hard to read. I don't know what happened this week when I printed my stuff off, but they didn't come out too good. All right. What I want you to do, all right, I copied number 11 from the previous page. All right. You can do numbers 11 through 31 right here. So it's just like 5 or 6 graphs that I want you to do. Don't worry about the directions. Just graph it. Okay? Let me zoom in for you. All right, I've got a sheet with these on here, and I'm going to go ahead and give it to you. But you're going to have a hard time reading it. Nuh-uh. Nuh-uh.